solution in solid state. So gas, liquid, and solid, we can have solutions in all three states there. And the key there is that it's a homogeneous mixture of two or more substances in single phase. The single phase could be either solid or liquid or gas. And by convention, the component present in the largest quantity is identified as a solvent. All the other components are called solutes. Now, aqueous solution, water is always a solvent. We mentioned this in chapter 4 when we deal with the molarity there. Okay, so when you prepare a solution, how does the solution compare to the pure solvent before you add the other components in there? Well, we have different types of solutions there, and this particular table actually gives you those different types of solutions there. We can have gaseous solution, we can have liquid solution, we have solid solution there. And again, when you see the term solution, more than likely, you will automatically think solution is a liquid there. Well, it can be in gas and it can be in liquid phase there. Okay. Now, homogeneous mixture and spontaneous mixing is something that happens in nature simply because when you mix two things together, they tend to form a homogeneous mixture if possible because they are energetically favorable and requires less energy to exist. Okay, so in this case, when you have pure water versus a sodium chloride water, a sodium chloride solution water there. Now, when you mix them together, eventually you end up with a homogeneous mixture there. Okay, water and the chloride ions and the sodium ions will mix thoroughly. You can't, and there is a uniform concentration. Okay, and when you talk about water versus things dissolved in water, you're talking about solutions there. Now, in cell membrane, basically you have liquid inside the cell, you have water on the outside of the cell. Now the thing here is that if you drink water and then the water is on the outside, okay, now water has a higher concentration on the outside of the cell compared to the things on the inside of the cell there. Water molecule will tend to enter the cell, passing through the cell membrane. Okay. In that case, and the salt, whatever solute dissolved in the solution, will remain on the inside of the on the inside of the cell there. Now, the thing here is that you probably still remember that movie, The Story of Pi. He was in the ocean out of nowhere and surrounded by water, but he's dehydrating. He said, "Why can't you just drink some water in the sea?" He was thirsty. Why can't he drink the water there? Well, the drinking the seawater actually is going to make things a lot worse. Simply because when you drink seawater, there's salt in there. There is higher water content inside the cell compared to the seawater. So if you drink some salty water, well, the water is not getting into the cell, which is what the cell needs to maintain the regular function of life. The water inside the cell is actually going to try to come out of the cell to equalize with the water content of the seawater that you just put in there. So when you are floating on the sea there, in the sea there, and when you're surrounded by a large body of salty water, you still end up with a situation where of dehydration because you can't drink that water. When you drink that water, that will make things even worse. So we need to. This basically indicates there's a motion, there's a movement of the solvent particle. In this case, the water molecule. Okay, so when you try to prepare a solution, the process, we call it solvation. The basic principle governing the dissolution process or the solvation process is what we call like dissolves like. If you have a polar solvent like water, polar solutes will be able to dissolve in there. Polar solutes, alcohol, or ionic compound. Now, if you have a nonpolar solvent, they will actually dissolve nonpolar solutes. Well, that is why oil do not mix with water, because they have different types of intermolecular forces there. Oil is nonpolar, water is polar. You put the two together, they don't like each other. They won't mix. Okay, so if two liquids mix to any appreciable extent to form a solution, they are said to be miscible. Alcohol is miscible with water. You can mix alcohol with any proportion with water. You will form homogeneous mixture there. Now, in contrast, though, when two liquids mix together, when you put them together, they do not mix. Well, we use the term immiscible. Now, what's behind this is really the intermolecular forces that we talk about in chapter 11. So when you have ionic compound, you put it in water there, water molecule, positive end of water molecule, negative end of water molecule. They will be attracted to the different charges in the ionic molecule, in the ionic compound there. So resulting in the dissolution. Okay. So here the ion dipole attraction are just the opposite. Sodium is being attracted to the negative end of water. Chloride ion is being attracted to the positive end of water. And that's why sodium chloride can dissolve in water. Okay. Now, if you have, and say you're trying to talk about the miscibility there, and you may think of this image there. If you have carbon tetrachloride, which has a fairly high density, somewhere around 1.35 gram per milliliter, okay, and if you have carbon tetrachloride versus octane gasoline, okay, those two liquids are nonpolar. Now, they should be able to mix with one another. However, you can actually separate these two layers of nonpolar solution with a water solution of copper sulfate. Now, the only reason we put the copper sulfate in there is because water is a clear, colorless liquid. If you put copper sulfate in there and you can dissolve, you can form a solution. The solution has a blue color. So if you pour carbon tetrachloride into the bottle first, and slowly adding that aqueous solution of copper sulfate, and then on top of that you put the octane in there, well, you will end up with a solution with 3 layers. This is how you prepare a cocktail. And you've got things mixed together in a cup there. But don't shake it. If you shake it, like dissolves like. Carbon tetrachloride will dissolve octane, resulting in the mixing of the two clear liquids there, and the floating blue liquid is the aqueous layer there. So here you can see octane and carbon tetrachloride, they have similar intermolecular forces there. When you shake them, they will dissolve in one another. They will form a single phase, a solution. But water, a polar component, a polar solvent here, will not mix with hexane or with octane or a carbon tetrachloride there. So this is what we call the like dissolves like. Now, this brings up the solubility process, the solution process there. So nonpolar solutes will dissolve in nonpolar solvents. That's a given. You get hexane is nonpolar, iodine is nonpolar. They will dissolve in one another. And polar and ionic solutes will dissolve, in general, will dissolve in polar solvents. So water, ethanol, methanol, alcohol will dissolve in water. Okay? And also hydrogen bounding solutes will dissolve in hydrogen bounding solvents. Alcohol can hydrogen bound. Ammonia can hydrogen bound. So those things will also dissolve in water. Okay? So what we have been talking about is the basic principle that governs the solubility of substances in different solvents there. That's like dissolves like. Okay? The substance will be soluble in a solvent that has similar IMF, intermolecular forces. And that's what we're looking for. So like dissolves like. Very important principle there. And then I guess over the spring break there, then the brown bear went to North Pole to visit his relative. And the two haven't seen each other for a long time, so they're playing. And all of a sudden, the brown bear pushed the polar bear into the water.